All right, so we'll start with other file format. We have seen three file formats. Just summarize. Last three was sequence file format. Then, let me write it here. Different file format in Hive. So we are almost in a closing point for Hive. Okay. So what we have understood here in Hive, this is a data warehouse where we will manage all the data which are stored in HDFS. We are running query on top of that data. We are providing structure to them. We are handling standard data. We are handling complex data. We are handling serialized data. We are running joining query. We are running all aggregation query. We are seeing how optimization will work. What is performance? What is partition? What is bucketing? Okay. Then using which file format we can achieve best performance in terms of performance. When I say how much total space they're taking from hard disk as an total size, and what is their computation time. Always when you talk about performance and optimization, it goes to 2 points. What is the time and space complexity? Time means how much time your CPU is taking to compute them. If it is a disk computation or if it is a in-memory based operation, both weight matter. And second, how much space you are taking to store that input. These two things is important to run or to process your algorithm. Whenever you run any job, behind the picture or scene, there is some algorithm running. Okay, so it depends on your time and space complexity. So that algorithm we have seen in our college, early college days, like data structure. There was one semester we have seen the data structure concept where we have different set of algorithm, that how order will be taken, how space will be taken, how binary search will work, how sequential search will work, how key search will work, how list comparison will work. Okay, so this is all the area which we have seen in Hive Data Warehouse, which is designed by Facebook, currently managed by Apache. So known file format is so far text one, which is a by default format. Well, text is by default format everywhere in Hadoop. We have seen from MapReduce to Scoop to Hive. This is our third module. Text file is a by default, so in bracket I can write this is by default. Then definition of sequence file, we have seen when to apply this sequence file option. Then third point was RC, record columnar. Good if you're running a query on large number of row. This is splitting your row horizontally and converting your data into key and volume types. So you can see that data using cat. The fourth option, which is more optimized and better than RC sequence in any other format, which is ORC. It reduces any input file 75% roughly. That's the rough number taken by different benchmarking. Now, fifth option, which we will start today, is Avro types. Avro file format. This is a SERDI. This is also SERDI, inbuilt SERDI. Avro is also inbuilt SERDI. SERDI, when I say serialization and deserialization. So I can call Avro SERDI, and the sixth one is Parquet SERDI. Now, when to use what? So few things already we know. Avro data will keep their metadata and data together in a part file itself. So when I process my data using Avro, or when I extract data from a scoop and write back to HDFS, and if I give an Avro file format while extracting data, while doing ETL, while scooping, so I see .avro as extension, but if I cat that result, if I concatenate that result using the cat command, so I can see there are some data and some metadata. So Avro schema is tend to present in their data itself, which means we have both things in one file. Parquet is keeping their metadata. Well, Parquet has a metadata separately also. Parquet does not mix their data and metadata. Avro is a row-based serialization technique which will convert your byte, which will convert your object into byte stream. And Parquet is a columnar serialization technique. For search pattern, columnar is much faster, okay, than any other file format. Intuitively, we can say that. We'll see this in performance when we will move to NoSQL types, because NoSQL complete concept, the graphics or whole crux of that NoSQL is based on the columnar storage, how we are storing in HBase or maybe MongoDB or Cassandra. So we're going to see anyway a bunch of NoSQL tools where we're going to compare which one is good for what. But today, as a part of this discussion, let's start Avro and then followed by Parquet. Now, to deal with this Avro, first I need Avro data present in my system, in my local file system or in my HDFS. Then only I can deal with this. So I have already extracted using a scoop, but if you have forgotten this, like you do not remember how to take data in Avro format, so those who know it's good, those who don't know, I'll write a query here. How can I extract my data from RDBMS to HDFS in this format, Avro format? So it's an inbuilt SERD types in scoop also. And what was the command to get data in Avro? It is scoop. So you're passing this tool name. Then you're saying you want to import the data. Oftentimes you're doing this only, import data, then hyphen connect. This is your connection URL, and here you pass which is your driver name. That's a Java database connectivity, because scoop tool is written itself is in core Java. So when I use this driver, connectivity may be better or faster. I can try ODBC and other driver also, but JDBC is the most common one. If I know some tool is written in that language, I'll be using this JDBC. We know those things, why JDBC and why not other database connectivity. What is my database name? I will write that database name, MySQL. Colon, this is in continuation with it, okay? Since the space is left, I'll write it here. Colon, double time slash, IP address of VMnet 1, virtual machine network 1, and which database. So from RDBMS or any, precisely if you're saying Oracle or MySQL, since we are using MySQL, we take a database of MySQL and we'll give a connection name, which is username, root, and password. Password we do not write, we encode that. So I'll give -p, which is password. After submission of this query, they'll ask later, what is the password? So password is not known to anybody. It's not visible. That's why we are using this, not writing password in a query. Then you define hyphen table, and you can define any table name that I need, let's say this table to extract, followed by target directory. So you can define target directory, or if you're not defining target directory, that's also fine, because by default it will keep it /user/Cloudera. Those are your fixed target directory. At last you define number of mapper. So number of mapper we know based on the primary key. Otherwise I can use a split by on this table and get multiple mappers running for that table data. Now the question is, where is this Avro format I will be writing? I can write anywhere. So before this mapper, I will use one small argument, and let me change the color for that. So here I'll be using hyphen as hyphen Avro data file. So for sequence, use sequence file. For Avro, it will be Avro data file. For Parquet, we'll see Avro data file. And then you define your uh, number of mapper, which could be 1, 2, 3 based on your total data set, CPU available. Once this is done, then after completion of this job, I'll go to my HDFS DFS hyphen ls slash, we know target directory is by default user Cloudera. So this is the location where my table directory will append. So same as your RDBMS table name, one new directory will be created. Inside that, we will have data. So this part is known to us. First, we'll go to HDFS and we'll try to find out if we have any data set available, which are a type of Avro. So there are multiple ways. First, I will tell you the easy approach. How can I do that? How can I take the data if data is already present? So my assumption is working in two bases. First, either my data is in LFS or in HDFS. Okay. If I have this two thing, then only I can start doing it. So I'll go to HDFS, DFS, -ls, and start looking for some Avro data file, if anything we have. Okay. So we see percent Avro. This job already I have submitted. I've extracted my Avro data for one table, which is a percent data. If you want to see this, you can go inside this percent Avro. And you'll find one part file, which has its data. So this is the part file. Can I read this part file? So I can see there is one 000 also. There is a success also. Let's do one thing. We'll try from beginning. Okay, otherwise you'll confuse from where I'm starting. So I'll delete this. I'll delete this target directory, which is already present. I'll delete, let's say, schema folder also. This is, I just created a schema for this one, percent Avro. So schema I'll create again from beginning here. What is the step? First, you'll open your MySQL. Then check for number of databases which are present here. Query we know, so databases. Pick up any database from here. Run that line. So the tables and check some result. Okay, let's say I will check table number TXN. Select a star from TXN. I can see bunch of records. Roughly there are 105. Total 8 or 9 entries are there. I want to get this data to my HDFS, okay, in form of Avro. So here is a query: scoop import ---- connect JDBC MySQL. I remember my VMnet one IP address, so I can directly write it. But for your case, you can check using ipconfig. If you're a Windows user, if you're a Unix user, ipconfig will work. 41.1/database name, username, which is root, and password is also root. Table name. So what is your table name? ---- table is equal to TXN. Try to match the spell, uppercase, lowercase. After this, target directory I will not define because I want to get that data. Or let me define the target directory also. Target directory is scoop Avro or TXN Avro. I can write any name, number of mapper 1. And here I will write ---- data file, because you can only make or manage data when the data is present. So this is the data onboarding stage where we perform data extraction. I'll give this keyword. This is giving error because this is Avro, not every. Root again. We'll wait for the output. This query is known to us, guys. We have seen this operation in a scoop. I'll just wait to get this output. After that, we'll see what is the next step. All right, so we get all these 10 records, okay? But size is slightly bigger than the text file, and they're taking some more time to get this data. So time is okay, but I feel size is big because if I use my text file format, so this size will be way less than this number, 673 bytes. Why? This is the reason why we are having more size here in Avro, because Avro is containing your data along with metadata. And to verify this, again, we'll go back to HDFS. We'll go back to HDFS and see this information. HDFS, DFS, -ls, and this was the folder name for Avro data. You can see it here, part m.avro, okay? Can we read this Avro also? Can we cat this file? I'll use a star and cat. So when I read this data, I see a few things. First, it is having my schema. If you read this line from here, this is all my schema, right? Table detail, metadata, and this is your data, which are extracted in, which are serialized Avro form, right? Now, data is not visible to us, so we know the data is secured. And second, the size is big because it contains metadata and data both. Now, to manage this, when you create a table in Hive, you separately need this metadata. Then only you can manage this data. And to collect this there are few stages. To collect this metadata from the table, from the file in HDFS, we have a step. And the step number 1, you have to download one Avro tool. So first, there are multiple approaches to do this. I'm talking about the approach number 1, or let's say the case number 1. Let me call it as approach only. Approach number first. Here I'll be downloading Avro tool. So download Avro tool. Obviously download from Google. This is all open source. Download Avro tool. You can check the version, okay? You can go with the latest version, or you can go with 1 or 2 version behind. So I'm using 1.8.1, or you can match with your Hive version also. What is the version of Hive, and try to get the same version which supports that Hive version. You can do that comparison, so you will not face any problem. Second point is, after downloading this Avro tool, I will copy this tool from my Windows to Cloudera using WinSAP, FTP, or any other FTP software. If it is directly downloaded in Cloudera, no need to move it. So that second point is optional. People who are downloading in Windows, they can use FTP and copy it to Cloudera desktop. Once this is copied to Cloudera desktop, then I will extract using this tool, using Avro tool, extract metadata, from file, from that part file. Okay, So we'll have to do this. Using Avro tool, extract metadata from file. And how can we extract metadata from file? That we'll see in our practical step. Then third step, right after second step, copy that metadata, okay, or write that metadata, write metadata to HDFS, obviously directory. And one thing you have to ensure here that file and schema are not referring to the same folder or same file. Schema is present in different location and data is present in different location. That's the ideal case, because if you keep both in same place, it will be difficult to manage. So this is important. Please ensure that when you're doing this, I'll take care in my practical. So you can check the same. Your metadata and data both will reside in a separate directory. Once I extract metadata, I'll write that in directory. So my data and metadata both are in separate place. Then I can, fourth step is my creating the table and passing that location, that this is the location for data and this is the location for metadata. How we will do that? We'll see it from here. So Avro tool you can download, just Google up. You can go there and type here Avro tool download. You can take any version, let's say 1.8.2 jar you are taking. Go to this site of jardownload.com. You can click on this download. So once you download, you will get bunch of file. Not looking for all. You'll see few Avro tools jar. And what is that few Avro tools jar? We'll see that here. So if this is my local, okay. If this is my local file system, and here is my jar file folder. So all the jar I am keeping here. One second. I think I've deleted that. Jar files, but yeah, once you download this, you get a jar files folder. This jar already I've extracted, and this is the name. You can see the Avro tool name. So from that file, you can search for Avro tools, this name. Whichever file has this name or jar file has this name, you can copy this to Cloudera. Exact name. There is some name Avro hyphen this also. So there is two file, one with tool, one with this. So get the tool file, because this tool will help us to extract our metadata. Now, what is the query to extract metadata? Hadoop jar. I'll be using this jar, Avro tools jar, and call a method get schema method. Get a schema and write this schema to location, let's say home user, which is Cloudera desktop, and I'll give this name as Avro, or let me call txn underscore av dot avsc. Avsc is the Avro schema. Space. I'll give the path from where I'm extracting this. txn Avro slash part m 5 times 0 dot avro. You can check this out. 5 times 0 dot avro. This looks good now. I think once again I have just given this location opposite. So this is the target file where I want to write it. So my source will be first and my target will go later. Once this is extracted, then I'll show you what information we will have here. So since this is a 30 types, your adding extra step for sequence, RC and ORC. We just created one table and said stored as RC, ORC or sequence, just one line, and the job is done. Here, this is some complex step to extract this metadata from the existing file. Now, can I check my metadata using LSLRT first? So last file, if you see, txn underscore av.avsc, this is the file. If I open this file, inside this, I have all the data in a JSON format, JavaScript object notations, which is a kind of key value format. Okay, so you can see it here now. This is very clear, and you can understand from this that you have one column name as CID, and the CID is having data type as integer. Then second column name is item, which has their data type as a string. Similarly, price, double, transaction ID, integer. Looking at this, I can say there are 4 columns which are integer, string, and double types. Okay, table name is this. This is the type, and this is the standard format of JSON, how they'll store data. Once this is extracted, what did I say to my, or what did I write here? Write metadata to HDFS directory. Okay, now copy this metadata to HDFS directory. Make sure not in the same directory where you have data available. Now I will write this to, let's say, I'll create one directory, HDFS DFS hyphen mkdir, and I'll create one folder with this name, Avro schema, and I will keep that schema inside this folder. So what command is required to perform this activity is hyphen put command, or you can use copy from local also. You can give this Avro file and write this to your newly created directory. So inside this, it will append. Always after running this command, you should verify. This is the validation step, cross validation step. So schema is there. Now data also I know. Let me take both in same place. Data also I know. This is the path of data, and that is the path of your schema. And now I'm good to create a table in Hive. Okay, what you'll do next in Hive, create table, and I need to pass my on location, not user Hive warehouse. So I'll create external table. This is important again to remember, because if you try to create internal table by default points out to user Hive warehouse. We have to point out to our on location, hence I'm creating external table, and name of this table is, let's say, I have not yet selected any databases. So let me create one new database as, we'll drop the previous one, drop database surdy. And since it has some table inside this, I need to cascade it. Okay. If you check now, so databases. Now I'll create one new database so that I can start it from query number 1 and use this database. Now create external table. Table name you can give as per your requirement. I'm giving txn avro. No need to type this column because that is unknown to you. So txn underscore avro, that's it. We are not giving Usually we define our column name here if it is the other type of format. For Parquet and Avro, Parquet we do, but Avro we don't define. Why I'm not defining it, I will tell you that in a while. Create external table, table name, and pass stored as the file format, which is Avro. Stored as Avro, and then you will give location of it, where this file, where this table will locate. So this table will locate at this directory where I am having my data. You can verify it from here. So this is my folder name where I have my data. Success is just an acknowledgement with a size 0. Now I can define here this location. No need to pass till file name. And why you're not passing till file name? Because what if you have multiple part file? What if you have multiple part file? You cannot pass. That's why one to one file. You should always pass till folder name or directory name. And last statement I will write, what is my table properties? So this is the TBL properties, and inside this table properties will define avro.schema.url, okay, is equal to, here I will type HDFS, and this data is present at which this metadata is present at which location? This metadata is present here in this. So I will give the full path name for this metadata. Paste and semicolon. Now look, technically, if you try to understand what I'm doing, I have given one table name, which can be logical, can be anything. Then I'm giving one location for data, and I'm giving this metadata location, but metadata of what? Metadata of this data only. So you have given location first of data and then metadata. Once this is done, you can start querying. Select star from txn underscore avro. So we're learning here how to extract data in this format, and we can manage that in Hive. So there is two things. First, you have extracted data from scoop to HDFS, from RDBMS to HDFS using a scoop, right? That's one. Second, maybe you are taking this data from some flat file location, some flat file location, or say some other server, some web server, which are giving you real time or near real time data. So in that case, this data is present already in my HDFS in form of Avro. So you know that data is present, but you don't know anything about the data, because data is serialized. You cannot read them, and if you cannot read them, you cannot make any sense. So how can you know how many columns are there in this Avro table? Using this tool of Avro, using this Avro tools, whichever version, let me take my own version, which I'm using. Using this tool, you are extracting metadata from this folder, and then you are managing data in metadata in Hive. And you're not writing the schema name here. Usually we used to write our schema name within this bracket, but if you have this metadata with you, no need to write it, because metadata will automatically take care of it. So this is how the structure of Avro is built. The second option to create this, I'll take any other table. Let's say use 12 p.m. I used to refer this database for you guys. So databases, sorry, so tables, so many tables. Okay, I'll pick any table, which is a smaller one. Describe out one. I feel this is still big. I take uh, txn. Let me take the out one only. Here I'll create one table. Create table out1 underscore avro. Now, what is my idea? What I'm trying to write here? From one table to second table. So already I have out1 table. This is my graph. Out1 table is there already. Let's say out1 table has m number of record, m row it has, and n column it has. So we have some m rows and n column, m into n total matrix. And out1 table is already present in SDFS. I want to create one new table, which is out1 underscore. I want to serialize this data. Okay. And there are many reasons why you're serializing it. So if you're serializing it also, you should know why you are serializing it. This part is very important. Is it an application requirement? Is it a user requirement? Is it a system requirement? Is it a query requirement? What you want to improve? If data is not secured, that's why you're doing it. It is taking more time for query, that's why you're doing it. Or in system you want to take less space, that's why you're doing it. So this why I think is very important. Out1 underscore avro. This is my new table, and I want to insert from this table to this table. Right? That's what we do using insert operation, and we call this is a intra Hive communication query. Insert will either do one by one or take from table and write to table. But in this table, I want to store my data in Avro format. So how can I do that? Now, there is no necessity to create external table. Into table, if you think this out1 table is already present. So if out1 table is already present means I already have my metadata present in SDFS, and obviously I have data also present in SDFS. Since this two thing is already present in SDFS, then I am doing insert. I'm not directly pointing to this SDFS. That's why I can create any table, internal table also and external table also, up to me. I'll create internal table, let's say. So internal table, and I will define all the column name of out1. So here is my definition of columns. I'll say customer number is integer, then first name is a string. Let me take just this two column, customer number, first name, and I'll take product also, last column, which is a string. Okay. Then you will have to say row format delimited, which is a common syntax. Fields terminated by, how you want to terminate the field. We often use comma. And then you say stored as avro. This is what one second, stored as missing by, sorry, this is fields terminated by. I've missed the by word. Row format delimited, fields terminated by, and is stored as avro. This is known as a inbuilt SERD. Hive provides you both things. Hive says you can use the SERD which is there already, like 6 different SERDs are there, serialization, deserialization, and Hive supports you custom SERD also. If you want to create your own SERD, you have that provision also. Now table is created and time to insert it. So I'm doing this now. My insert is already done. Sorry, my table creation is already done. I'm going to do this insert now. What is the query here? Insert into, we don't write into, insert overwrite table. That's the syntax. You define your table name, which is out1 underscore avro. And from where you take this? You take this from select. I'll not say star because I'm taking only 3 column. I will write individually. A dot Cust number a dot first name a dot product. From table name, which is out1, take enter. We'll see after this operation how much total space this folder is taking, and is their data serialized in HDFS in form of Avro. Okay, so here is my total time taken by the system. This is the CPU time. They have written some number of rows. So output is there. Select start from out one underscore Avro limit 10. So just 3 columns is extracted. And if you go to your HDFS, you'll find HDFS DFS -ls user Hive warehouse. This is your internal table. 12 pm dot database name slash after database table name, and table name is out one underscore Avro. This is your data, and if you want to see few records from here, you can use head command. So see top few records. When you type head, you can see your schema. This is all your schema, and these are your few records which are serialized in Avro format. So 2 options we have seen. First, if data is already present in HDFS and I want to manage them. Second, if I want to create one table and from there I want to extract it. The data is present in text, and while writing, they are converting that in Avro format. Second type format is Parquet file format. Okay, Parquet is comparatively easy than Avro because we're not taking this extra step. We're not downloading Parquet tool or something. So how the Parquet is working? Same way, I will take data from scoop using a query. And what will be that query? So scoop import. I take the same table, let's say, and I only want to change here. I'll say Parquet file. So instead of Avro data file, I'll say Parquet file, and target directory we do not define in case of Parquet. So it will keep new directory. It will create one new directory. I'll take the question in a while after completion of this Parquet. Parquet file minus m is equal to 1. I think this is good. Enter. Root is a password. So same number of records extracted, and let's say this data is DFS-DFS-LS. This goes to user Cloudera. That's why I'm directly going to user Cloudera, and takes in folder should be there. TXN is there. Inside this, I will have my result slash TXN. Okay, this is my data, guys. This is my data, and this is my metadata separately. Here, if you ask me, we have just data or metadata. There you have both data also, metadata also, but your metadata is separately stored also. This was not the case if it is Avro. Okay, then let's go to question side now. The question is, if the data is serialized and stored in byte format, why we use row format delimited? This question is for first query, Hatim, or the second query. From the tool, I have extracted my metadata, then I manage this queries for that, or this queries for second one. If you can precise me this, because I'm confusing with this question. Because when you say if the data is serialized, where your data is serialized? Your data is not serialized. You are creating one empty table. No. You misunderstood this point. When you say if data is serialized, data is not serialized. Data I am serializing from out one table. We have seen two cases. My first case is already I have data present in HDFS. My first case is already I have data present in HDFS where I have my data along with metadata, which is mixed, right? Agree? Then point number two, we have extracted metadata from this HDFS Avro file. We have extracted this metadata from Avro tool. Then we are managing their metadata and data both in HDFS separate directory, creating one table in Hive space, create external table, any table name, let's say TBL, and then you're writing stored as Avro, because you'll have to explain which format you are going to store this data. If you do not write this explicitly, then it will consider it as a text file. By default is a text format. After that, you pass your location, which is any location within the single quote where your data is present, and then you are providing a TBL properties where you are passing your schema location. This is one thing. I'm sure your question is for second. So what you are saying or stating in the question number second, if the data is serialized and stored in byte format, data is not stored in byte format. Data you have in the out one table. This is not the serialized data. This is the text data. This data which is present in text out one, which is my source table, this is the text data, and you have created one new table which is out one underscore Avro. This is your table which does not have any data yet. This is the empty table you are creating using stored as Avro format, and that is the reason you are writing fields terminated by, you're writing this two statement, row format delimited, which we write with our regular statement, and fields terminated by. Remember, this is empty table. This does not have anything yet. You are inserting from here to there. You are inserting from this table to this table. So when you're inserting from this table to this table, obviously you need how your data is going to stored in this table, because this table is also pointing to HDFS, isn't it? User Hive warehouse. This is the location where it will be pointing. So I repeat, don't think that there my data is in Avro format. If data is already present in Avro format, then why do I create this table and then write it here? I'm creating this table in Avro format so that I can convert this text file format to my Avro file format. And that is the reason I'm writing it row format, delimited fields terminated by, because this is empty table. If I'm just pointing to HDFS file, which is a type of Avro, then I will not be writing this to a statement. So there is a difference. Hope this is clear. So we are going to check for Parquet now. And for Parquet, we know my data is present already. My metadata is also there. This is very easy. We can check their metadata from, let's see the data, okay? Just out of curiosity, we will try to display this in console. I'll see cat, size is big, see few records. So here is the opposite. First I have data, then metadata. Earlier case was data first, metadata first, then data. There I have my metadata later, data first. Okay, I can check that schema from here. Well, I already know what is my column name from this table, so I can use desk. So this is one option. Since this is readily available for me, I'm checking from here. If you guys want to check from here itself, you can check their metadata folder. You'll see the schema name. So HDFS, DFS, ls, user, Cloudera, and warehouse. Sorry, user Cloudera and PXN. So no need to do anything. You create one table in Hive with this metadata CID, item, price, and TID. Create, let me use SRD types. So tables, create table, and obviously external table. What is the table name? TXN underscore Parquet. And you have to define the column name here because the schema is already there. CID is integer. Item is a string. Price and TID. So price is double and TID is integer. Okay. Then next, do we need to format that row format and all? Not required because data is already present. We're just pointing to that data. So I'll not write any fields terminator or row format delimitation. I'll write here my data location. Let me call X, or I have to check this from the syntax. There is actually a SRD package, so I'll have to write the SRD package. I'll take it from this file. So already I have given this first line. This is what I need to pass it. So you cannot remember this thing, so I'll have to take it from Google only, or the packages. This is a complex name. Just mapping this in the same line. Row format SRD. So till this output format line, I'm just going to copy and paste because this is the defined type. Copying it from here and pasting it here. When you're pasting, check the special character, single quote and all. If all looks good, you can go with this. It's stored as. So it's stored as when you say Avro or Parquet. Okay, there's two things. If I say stored as Parquet, this is one. stored as, and then you are writing separately these two lines. First is input format and second is output format. So I'll explain you what is the difference if I write externally or internally, and there I need to pass my location. What is the location of this data? User Cloudera TXN, right? Enter, and we'll see if data is mapped or not. Select star from table name TXN underscore parquet. So data is visible, but before going to see the data, you can run any query there to Avro and Parquet. Now, what do we mean by this thing? This complex stored as this line. This means exactly stored as Parquet. If I write stored as Parquet, or if I write this, both are same thing. Because internally, if I create any table in Parquet format, and when I'm going to check their definition using so create table name, then I'll see internally it is not giving me this. Internally it is giving me this only. So this is nothing but a packages. These are the packages which are defined by Hive for Parquet file format, for Avro file format. Because there's one thing, you have first created this data. Now table is visible, data is already stored in a Parquet format. Can you do one by one insertion like this? Insert into, can you say insert into txn underscore parquet, and let's say you want to write first column and last column, which is CID and TID. So CID and TID, and you want to write values 200 comma 10,000. Okay, and enter. So one by one insert. One second. TID. What says are not found among regular columns. Actually, my column name is different. 200. Insert into table name values. Dynamic partition columns. Okay, let me try doing this for I'll do this for Avro. Okay, I'll see Avro takes single insert or not. Use 12 PM. So tables, we just created one tab, Avro table. This is the out1 underscore Avro. Describe and insert into out1 underscore Avro values. In Avro, I want to write only for product, and there I'll say product values, which are some type of machine product. So here it is working. Parquet does not take a single insert. Avro takes it. So Parquet you can only be able to do extraction first, and then you can manage the data, or you can create one table, one plain table, just like out1 Avro table, and then from one text file table, you can write in that second table. So while creating the table, you have to write is stored as Parquet. So I think there is one base or boundary line between all the file format is this. If you're using this file format, Text file, no need to write anything. There is one statement for text file also, is stored as text file. So you can use it using this, using not including this in line, both are same thing, but by default is text file only. If I want to store in sequence, I'll say stored as sequence file. So I'm only changing this part every time. I'm only changing this part. So changes, how to do, why to do, know few reasons, why you're doing this, for which reason, and then query point, their performance time, their individual reaction time, you can compare. So the best practice will only come when you check all the format, take your system, write down in some notebook that this is taking this much time, this much time, this much time, and get to know the conclusion from your own end. Because if you read the textbook, it is written that this is faster, this is not faster. We can still collect, but if you're doing practicals, that's more clear and louder. So this is about all the file format, guys, including SERDI. Now we'll see, so far all the application or all the query we are running on MapReduce execution engine. So we'll run some of the query. We'll see how this works in TEZ also. Because MapReduce's typical approach, you take a time, especially for DML, because any DML operation, which are kind of count operation, insert operation, delete operation, right? Update operation. So every time they're taking time, because every time they're submitting that query into map and reduce. I don't want to take the time. I want to use some kind of in-memory approach or caching approach, data caching. So data caching or in-memory is fast because they do not write. Let me write it here. If suppose this is my interface and here I'm explaining you the concept of TEZ. If you ask me what is this TZ, this is also one type of execution engine, the same which we are seeing in MapReduce, but MapReduce is slow because they will write their intermediate output to disk. Why your map side join was fast? Because map side join is doing this approach. They are taking few set of data or a small table data into memory. So when they're taking into memory, it is not reading from disk, it is reading from the same concept we have in TZ also. Now my interface is this. I'm not doing any fancy thing. I'm running my query from this interface, which is a Beeline. Beeline is also a Hive interface, or maybe I'm writing directly from Hive cell. So different Hive warehouse interface are there. We call HWI or CWI, client wise interface. This is going to their driver. Then after driver, this is going to compiler. After compiler, this is going to metastore. After metastore, it is reading and passing. Okay, this is mapped. And then this is sending to execution engine. I'll write execution engine. We already know the case of MapReduce, how they do, what they do. If it is TZ, assume, let's say, because we're going to late many things here. So let's just say my execution engine is TZ, okay? And I'll show this in GCP. I'll log into my GCP and probably we'll see this practical today. So execution engine, I'm running the same query. It is taking to this TZ, and then TZ is further distributing this query to resource manager, and then resource manager is submitting this to node manager. And obviously their data node, let me call nm1, dn1, based on the query. If this is a large query, it is distributing to name node manager 2, data node 2. After processing the map stage, here we do not call map task and reduce task. For TZ, the terminology for map and reduce would be map vertex, and reduce vertex. So what do we mean by this vertex thing? Map vertex and reduce vertex means they will write their intermediate output. After mapping is done, it's not going to hard disk. It is going somewhere in the cache. In the cache. So in cache, when other task is reading, okay, other task from same map side, which is not the case because mapper and mapper will not communicate. But reducer is trying to read it. Reducer will not read this from disk. Reducer will take it directly from this cache. So what DML you're running, you can execute in DZ. There's one option. You can execute in a Spark also. Spark is ongoing module, upcoming module. We'll see that is Spark. TZ is applicable only with Hive. You can change it to Pig also. So this is kind of DAG algorithm, directed acyclic graph, which are making my query faster, right? Now, after knowing this reason why this is faster and how my other execution engine may work, there is other tool which is very similar as Hive. All the query which I'm running in Hive can be taken care by that tool also, and that tool is defined by Cloudera, not by Apache. It's not a free source tool, and that tool name is Impala. So all the names you'll find related to Impala is, by the way, wild animal which is very fast. It looks like a deer, the family of same, but they're way faster than deer. So Impala, the concept is same. The same thing, Impala is much faster than Hive. Now, why the Impala is faster than Hive, that we will get to know when we compare Impala and Hive. So query wise, all the query which you're running in Hive, exactly the same thing, only the internal algorithm is different of Impala. So that's why if I give a difference between these two, first we'll check for this, then we'll check for this. So Impala difference, point number one is Impala gives you fast start. Hive gives you cold start or slow start. You can say cold or slow. Point number two, Impala is based on in-memory model. In-memory model, or they're building the cache. Whenever you say in-memory, it's similar as cache. Hive is not based on in-memory. Hive is working on disk computation model. They're computing on disk. Point number third, Impala is not dependent on MapReduce. Impala has their own set of daemons, which we call Impala daemons. We call Impala D. So wherever I have node where I'm running Hive, I'll be running Impala daemons also. So Impala daemons can process or can run a query much faster than this. One example will have for what type of query Hive is better, for what type of query Impala is better. So Impala daemons here we have as execution engine, and Hive execution engine is known to us, and this is MapReduce by default. Right? We have checked that using set hive.execution.engine, and the answer we get was Hive. Point number four, Impala is not a fault tolerant. Impala is not a fault tolerant. Now, when you're working with a big data, this is one of the biggest feature. Fault tolerant is not available or applicable in Impala. Why? Because this is in memory. If I'm running a query, okay, what do I mean by this fault tolerant? I'm explaining that. If I'm running a query, let's say select start from table name where country is equal to India. This is the query I'm running from Impala. And that query is supposed to extract billions of results. Okay, let me present this graphically. So I have a query here. I'm saying select, or let's do joining. So I'm saying select a dot name and b dot grade. So I need b name and the grade. A dot name, b dot grade from table name, which is exam, which is exam, exam, which table A. From there, I'm taking name, and I'm joining this on result, which is table 2, result B, and I'm doing left join. So I'm taking all the name, give me all the name and their individual grade. Left join, left join, and I'm running this on A dot. Sorry, join is already written, so no need to write it here. Exam A, join, I will write it here. Left join, result B on A dot, let's say roll number, A dot roll number is equal to B dot roll ID. This roll number and roll ID is a common column which has some common data. The moment I run this query, what happens? Let's talk about Hive. Talk from the Hive perspective first. So when you run this query, what Hive will do? Hive will check this exam table and join table. Then they will find out total result which are required by this query, and they will check the size. So based on the data size, let's say the data size is getting some 1780 MB of total data. This is the required data for this query. So they will run a MapReduce job according to this, right? They will run a MapReduce job, and how many block will be there? If 1780 MB is my total data required to scan and filter according to this query. So 1780 MB will be divided by 128 MB, which is my by default block size. We can use a quick calculator here. 1780 divide by 128. If this is giving me 13.9, I'm sure. I know there are total 14 blocks. Let's just calculate the 14 blocks. Individual data, 13 blocks are fully occupied. Last block is having some amount of data. Now, to process this 14 blocks, you need 14 parallel. If you want to submit this 14 blocks parallel, okay, remember this, because it's a trivially parallelized model. We call it a trivially parallelized model. So I want to run a parallel execution on my cluster. My cluster can have n number of boxes, n number of node. So I can have 5 node, 10 node. I have seen thousands of nodes also working for some of the cases. Working in a large internet companies like Amazon, Walmart, Google, sitting in the petabyte data is very normal. So having 100 machine, 200 machine, 1000 machine is everyday task. Now you are doing this query trivially parallel. So to process this 14 block, I need minimum 14 core. That's what I can explain it. To process this 14 block, I need parallelly 14 core. Now, I don't care this 14 core is from 1 machine or 2 machine or 5 machine collection. I just need this core from the cluster. Since I'm saying I have 5 machine, let's say all machine has 2 or 5 has 3 core individually, which means 5 machine, each machine 3 core is total 15 core. So I can submit this 14 blocks parallelly to 5 machine, and then they can process based on their CPU, how application master is tracking my task. And we know the internal process. How can we track? What's the URL? Currently, I'm just talking about the parallel execution. Now, when I'm processing this, and this all insights we are collecting from Hive, then we can relate the same thing. As soon as we get this Hive, we can replicate the concept of this Hive to Impala, and we can prove that why this is not a fault tolerant. That's the point which we're trying to understand. So 14 block, 14 core parallelly. Let's say they're running. I got 14 core from 5 machine, and I'm running this 14 task. Can I call this as a 14 task? I'm running all these 14 tasks in my cluster. And what is this cluster size? In this cluster is group of something. So group of machine I'm calling a cluster. I have my 5 machine. So 5 node is there, or let me write them separately. I have node 1, DN1, node manager 1, DN2, node manager 2. This is the slave and they configure together. DN3, node manager 3. Similarly, I have DN4, node manager 4. And last node, DN5 and node manager 5. So I am doing one task processing on DN5. Okay, let's say the task number 12. We have total 14 tasks. So task number 12, let's just assume task number 12 is running on this DN1 and NM1, this DN5 and NM5, this machine. And task 12, we can track every task. We know how to track this. So we can check every task and I can see this task T12, task 12 is completed 54% on this machine. Okay. And after some time, due to network issues or due to environment failure, due to service down, you lost this machine. You lost this machine, or maybe you lost that data which is present in this machine. You lost that data block itself. So two cases, if block you lost means you are processing this block only, this 54% task which is done of this block only. So 54% total execution or the progress you have lost. If you lost the block, you cannot resume from 55%, 56%. You're stuck here. If you lose the machine, let's say this DN5 itself is lost, then this is a disaster. You lost the machine, so you lost the task completely. What do we mean by fault tolerant? They're the same task which I'm running in DN5 and M5. It will try to find out that do we have the same data? Do we have the same data where my 54% task is already completed? Let's say this is block number 12, right? Because task is working on 12, so block number 12. This 12 is present in this machine. We know that. That's why my task is running on that due to the concept of data locality. But we are working with the replication factor also. So the same block is present here also and here also. So 12 block I have at 3 places in my DN5 one machine, DN2 and DN3. If I'm losing this machine, still I have DN2 and DN3 up. If it is a fault tolerant model, what they do, they will pick this 54% task from 55% using other, because their progress report is continuously they're sharing with the master node. So this 54% update is there with your resource manager. So resource manager will find out, okay, there is one block. Let's continue from 55%. So maybe it can pick up this DN2 to submit the 12th block, which is 12th number of task, and it will start from 55%. This complete graphics or the flow is known as your fault tolerant model, which Impala is not doing, because Impala is based on in-memory model. Your in-memory can be so fast but cannot handle large volume of data. If they are processing large volume of data and they fail somewhere, they're trying to get this concept, as I have read the last research paper of Impala. They're not yet created the fault tolerant model. They're trying to build maybe in upcoming model or version or release of Impala we may see. But today I have many options for Impala. The popularity is bit less because I can use Impala to get my query done in less time. I can use TZ, I can use a Spark. So all these 3 options are there. So anyone I can use it. No, not necessary that Impala only can take care. TZ and Spark, all these three works with the same concept. However, Hive is fault tolerant because Hive is based on MapReduce execution engine. So we can say this concept is applicable here. And some more features are there. So I'll go back to my desktop where we have this, things present. Okay, let me open this Impala image. We'll spend a few more minutes here. So this is Impala image I've collected from Cloudera. Here we have interface to communicate with Impala. We have this mini interface, Hive, JDBC, UDBC, Impala cell. There's a separate cell for Impala. I'll do anyways practical for Impala. Queue is there. Then Hive meta store, Impala status store, HDFS name node, HDFS daemons are there. These are the execution engine. What they do internally, they plan a query, they coordinate, then they submit to execution engine. Okay, and I can use this Impala on Hive because Hive data is present in HDFS, and I can use that in HBase also. So here is one thing which is common in when you discuss about Hive and Impala. One thing is common, that Hive and Impala both share their meta store. So Hive meta store we already know. This is this is going to MySQL, right? That's the metadata location, and data location for internal table is user Hive warehouse. Meta is store for Hive. Okay, whatever meta store you have or whatever data store you have, this is exactly same as Impala. So Impala is actually referring their meta store. So if you create any table in Impala, that will be visible in Hive cell. If you create any table in Hive, that will also be visible in Impala cell because they are sharing each other meta store. Basically, I can say Impala is pointing towards Hive meta store. So whatever data, metadata is present, I can check that in Impala. Why I'm using Impala? So now I'll clear the application front. I have personally used Impala to demonstrate anything in very less time. So if I want to, let's say I have completed my last 5 Scrum story, and my business I'm doing, let's say this is in um, UAT mode, user acceptance testing mode, okay? And user from business side, they want me to run a query and they want to see the data in Hive. If I'm running a query related to this, which are kind of big query, select A star, B star, C star. If I run this query in Hive, what will happen in production? One of the query, if I share this, took me 84 minutes also. So one of the query takes this time also. So you have very limited time for demonstration. Let's say that is 40 minutes. If you're running a one query, in one query itself is taking large time. So what is the option there? To decrease the total time and increase the performance, you are doing the same thing, just you're increasing the performance using this Impala. Okay, so it's not changing the output. It is only created for your less time. So you're decreasing the time and increasing the performance. That's why we have this two things. Output is not changing anyway. So Metastore they're sharing, and now we'll see first Hive, TEZ execution engine, then we'll come to Impala. Because Impala is a separate tool. To get that Hive thing running, we'll have to log into our GCP login. Okay. I hope you guys have created. If not, again, make this cloud readily available. So if you're facing any internet issues, you can directly connect here. By default, your execution engine of Hive in GCP is set as TZ. I'll show you that also. To start this, we'll click on this left panel. Go to option number compute. You'll find compute engine. You'll click on VM instances. You can go to this and start. And this will take 20-30 seconds. Once they're started, we can log in then. So this is, I think, not even 3 seconds. Your system is up now. Take this IP address, and I have already key with me, so I will connect from here. CD desktop. What is the command? SSHI. I'm taking my key, my username, my password. Sorry, IP address. And you can type sudo gps. Just to check this, you can run sdfs dfs -ls /. So we can see all the files and folders are present here. Now let's go to Hive cell. So this is already running. I just need to start it and spin the cluster. So Hive cell is there, and so databases we can do now, right? These are the database. Now execution engine. So what is the command? Set Hive execution dot engine and semicolon. You can see the answer is coming as TZ. So practically we'll prove here. We'll run a query, okay? Use any database. Let's say I'm using the existing database. And from here, I want to run a query. Select a star from emp underscore bucket. This is some table which has some data. Now, here I will try to do insert operation. Okay, any DML. I focus only on DML. So describe and table name, employee underscore bucket, ID name and salary. I'll insert one row, insert into emp bucket and values. Then I'll type integer, let's say, which is not there. I'll try to write 5, comma, name, then their salary is 39,000 bucks. Enter. If the same query you're running in MapReduce, what happens? As soon as you fire this in your terminal, immediately, so this is the flow again. From client it goes to resource manager. So you're a client. You're currently running this query from this client, and the further communication it goes to resource manager. It looks after the data using node manager. Then resource manager is having HDFS parallel to this. and HDFS will submit this query to their node manager. Once they know data about once they get the blocks information from name node, write this as name node. This is name node. Okay, so you have bunch of uh, slave machines available: NM2, DN2, NM3, DN3. This is what is a typical approach. It goes there, then based on the progress, they start communicating here. So this is like request, and this is your acknowledgement. Flow is same here, not changing different, but just because of disk computation, this is taking more time. You will see the time here. If this is taking more than 10 seconds also, I don't see this will take more than 10 seconds. So 18.22, that's still okay, because if I run the same query in MapReduce, okay, let's run here. I'll take any table. So tables, and use out1. Sorry, select star from out1, limit 5. If you write one entry here, insert into, you just give one column. Insert into, what is the first column? Out1 is customer number. So insert into table, you define column name, values, and give a value 4007000. Enter this and observe the time, and in fact the log file. What is happening currently? They communicate to resource manager, then this is resource manager is launching one application master, then your job is started. Here when you submitted, you did not see any that detail. When you started, it launched one application, and then directly it started their vertices. This vertices is coming due to vertex only. So number of map is 1 by default set. Reducer must be set as 2. Mode is sorry, the total number we are running 1 and 3. Yeah. So container is mode where they are storing the process like a spillover output. Status is succeeded, total 1. This 3 is coming including of this 1. Okay, so 1 plus 2 is 3. Completed 1 out of 3, running is done, pending is done, build is done. And this is your output. If you want to see, you can run a query. Select a star from emp underscore bucket. So you'll see the last entry here, which took you total 18.2 seconds. Okay, here almost 4 times. This is just a one machine performance. Okay, if you want to run a count star query, if you run a count star query, and then you check the output, I think this is just a 0.59 seconds. What happens whenever you say something is caching operation or in cache or in memory operation? There's a two stage. It does not directly read from the cache, because when you run a first query, for that table, so this query will build the cache. This is your cache building stage. Because if cache is not built yet, then how can they read from cache? So your first query will always take some extra time. Okay, your first query, if it is in memory also, I'm explaining from that context. If it is in memory also, this query will take extra time, some extra time, because first they're building the cache. Then when you run a second query again, same time, let's say the first time they're building the cache, so they took you total 11 seconds. When second time you run the same query, this cache is already built. So this query will directly read from the cache, and hence this may take 2 seconds or 3 seconds. So first time it is taking 11, the same query, the second time it is taking 2 because it is reading from your cache location. Okay, so this is why this is the concept of every in-memory system. Not first query is always a cache. Always your second query onwards, they are optimizing the time. So this is about, guys, TZ. You run any query, you submit any operation, DML, DDL, DRL. DDL, they're not running any query on execution engine. DRL also they're not doing anything, but for DML definitely they're doing it. So for whatever discussion we are having here, this is only for data manipulation point, not for DDL increment, performance increment, not for DRL, because DDL and DRL is anyway just done in less time. Only concern is your DML operation. Okay. Performance reason we know what time, why they're taking. Now, one more thing, Hive will Impala will see Impala after one last point of Hive, which is related to scope. So Hive can directly extract the data and create a table using a scope. So I can set my context this way. Scope can extract. A scope can extract data from HDFS, and directly, sorry, the data from RDBMS and directly write it to or manage it to, I'll say manage, writing is a different word, and directly manage it to Hive warehouse. So this is good option. Scoop can directly write data and that data directly extract data from RDBMS and can write to Hive. Now, there's a question arising actually. I'll ask this question. If you can note it this down and search today, tomorrow we can have, if you find any answer. So first point is, I have my data stored in RDBMS. Okay, the flow, the typical flow I'm using, like upstream source, then downstream source. This is your downstream source, right? All the website data is coming to this RDBMS. And from this RDBMS, which can be any database, you are writing this data to HDFS, okay, using ETL tool, and that ETL is scoop for us. After writing this information to HDFS directory, you are managing this data from Hive. So I can represent it this way. Hive is present right here, top of your HDFS, and then Hive is pointing to this HDFS, right? That's what we are doing so far. Scoop is extracting to HDFS, Hive is pointing if it is external table. So I can create external table and point to HDFS directly. This is one flow. Now second flow, why don't you directly take this data from RDBMS and write to Hive directly? Both are, you don't find much difference here, but both are created for different purpose. First purpose is you are extracting all the data from RDBMS. Let's say this RDBMS is MySQL according to our scenario, and RDBMS, this data which you're storing in this box is related to some healthcare data, some hospital last 200 years data we have. Okay, let's say this is Government of India information. They're storing all their public census report, their health report, their cholesterol level. I believe so many factors are there in this healthcare data. This is last 150 years. This is last 150 years old data, which I'm calling as a historical data, because the scoop is designed to extract the historical data, not the real-time data. That's one line difference we should remember. Never say scoop is meant for real-time. Scoop is for historical, and that too it can only target RDBMS, not any server. For server we have, for all the application we have a solution. Scoop is not built for that. Okay. Scoop is writing this all 150 years data to HDFS. So can I say I will have 150 new directory if there are let's say there are 150 years, and I will create some number of table. So out of this 150 years, with total number of table which is present with me is somewhere 700 table. Some table are having urban data, some are having cosmopolitan city data, some are having rural area data, some are having people who are aged between 30 to 50, people who are less than 80, like teenagers, people who are old more than 50, people who are senior citizen more than, like I've categorized this table, okay, and I've stored only those information which I'm looking for. Now if I extract all this 700 table, it will create 700 new directory in HDFS, right? If I start extracting, like I do import all tables. So import all tables will take all the table and write in HDFS. How it is happening, how much time it is taking, that is completely depend on the cluster size. What is my cluster size? I'm not going to that area now. That is a calculation, mathematical area. So 700 directories are created for this 700 table. Now, second thing, this is dependent on application. I'll not say this is good or this is good, because favoriting the flow won't be justice for your application or problem statement. My first problem is this. The government of India, who is my client, who has given me this job, they're asking me, I don't need all the data. I need only people who are, I need those data which are only which are also, they're giving me this task, they're writing in English, extract all the data, extract all data from database to HDFS. This is already done. And filter those result, filter those result or those data which are after 1980. This is the year. So my business, my government is asking me that extract the whole data. I need all this data in central repository so that later on I can do analysis on that. But currently I only want, this is the current requirement. Currently I only need data which are more than 1980 year. So more than 1980 year means 1980 to 2025. Take the current year. This is roughly 40 to 41 years of data, right? So I will write some programming. I will use Scala, Python, or Java, and I will try to extract those data which are falling in this category, 1980, more than that, and write in some other folder. So this is 700 directories folder. Let me call this as a data lake. We use some terminologies here. So in company, we call this is a data lake, or we call this is a staging layer, okay, where we keep all the information. Now, out of 700 table, only 13 table, I'm just taking a random number again, only 13 table has record more than 1980. Less all the table are having less than this year. Okay, so 13 file I should call, 13 file or 13 directory. 13 directory is only falling under this category. So you are managing using Scala programming language or Python programming language. You're transforming this result. Okay, transformation is there, aggregation is there. Transformation means maybe some person age, you're filtering based on age, you're filtering based on the disease, the person disease, okay, or any other factor. So you have written some transformation rules using this programming language, and you're writing well defined filtered data in new directory. So you scanned all this 13 directory and you're filtering all new result, which are transform result to new directory. Okay. Now this is one case. This is the case number one, where business is asking you to extract all first to HDFS and then do analysis or write program to handle few set of directories, create a new directory, and then from Hive, you can create one external table and manage that table using Hive. Okay, because if you know this data, if this is some kind of text or Avro or Parquet data where I can see the schema, I can directly create one structure, one DDL in Hive and point to this new directory using external location. Case number one. Quickly, case number two. If your business want you to do this, extract all data, extract all data from database, to HDFS, and you don't want to filter, you don't have this condition, you don't say that I need more than 1980 or less than 2010, you don't say this condition, there's no filter query. You're saying I want to manage all this 700 table. You want to manage all this 700 table along with their patient, their age, their other factors. Then you will use the second approach from RDBMS to directly Hive. Okay, again, I'm not putting any filter query here. I'm not asking that tell me only people who are having BP or find people who are having cholesterol level, who are having cholesterol level more than 2.6. Okay, so I'm not using this kind of threshold. I'm taking all the table, right, directly writing this to HDFS, sorry, directly writing to this Hive and managing the table. So you have to remember this type of problem statement, because it's not blindly we're following one flow. Okay, this is HDFS, this is in practical also, or in interviews also, if you say this, because this is the flow we are going to use in project. If you say this is the project, they can ask you, they can argue you why you are using HDFS, why you're not extracting data directly to Hive. So you should be able with the answer that I have to further filter or put some threshold on the data set which is extracted from RDBMS to HDFS, and then later what is the new directory or new data set created after my transformation, I will manage that in Hive. This is one. If you say whatever data is present, I want all the data as it is, like full snapshot, then why you need HDFS? Why don't you directly manage to Hive? So two things, two different requirement. The processing of Impala will start tomorrow.